Let's prove that if a and b are both odd integer, then a to the power 4 plus b to the power 4 minus 2 is a multiple of 16, or a to the power 4 plus b to the power 4 minus 2 is divisible by 16. So a comma b are odd integer. If they are odd, then obviously we can write this as, then a must be equal to 2m plus 1, b must be equal to 2n plus 1 for some integers m comma n. And so we can write a to the power 4 plus b to the power 4 minus 2 equal to 2m plus 1 to the power 4 plus 2n plus 1 to the power 4 minus 2. Somehow we want to show that this expression is a multiple of 16. Observe that if I expand, then I can get 1 as the constant term, and 1 plus 1 is 2, 2 minus 2 we get cancelled, and maybe we can get this expression to be a multiple of 16. However, we'll not do that. We'll assume that students are not aware of the binomial expansion. We will do it without applying binomial expansion. So what we'll do is, we'll write this expression as twice m plus 1 whole thing square minus 1 square, and then twice n plus 1 whole thing square, again whole thing square minus 1 square. Now we can apply the formula a square minus b square equal to a plus b times a minus b. So we'll obtain it as twice m plus 1 whole thing square minus 1 square, that's a minus b, times twice m plus 1 whole thing square plus 1 square. Similarly, this can be written as twice n plus 1 whole thing square minus 1 square, and then twice n plus 1 whole thing square plus 1 square. 1 square is just 1. Again, we can apply the expression a square minus b square is a plus b, a minus b. Let's just expand it. We know that formula a plus b whole thing square equal to a square plus 2ab plus b square, and 1 will get cancelled, and we'll get 4m square plus 4m, 1 gets cancelled. How about this one? We'll get 4m square plus 4m plus 2 plus 4n square plus 4n, 1 will get cancelled, and 4n square plus 4n plus 2. Now once again, let's recall what we want to show. We want to show that this whole expression is a multiple of 16. But at least we can take 4 common from this expression, and then 4 common from this expression. Let's take 4 common. Not only that, we can take 2 common from this expression. We can take 2 common from this expression, and then 2 common from this expression as well. So we can get 4 times 2 common, or we can get 8 common. So we know that this expression is multiple of 8. However, we want to show that this expression is a multiple of 16. So when we take 4 common, we will be left out with m square plus m. And then when we take 2 common, we will be left out with 2m square plus 2m plus 1. Again, when we take 4 common, we will be left out with n square plus n. And then when we take 2 common, we will be left out with 2n square plus 2n plus 1. Alright, so we want somehow another 2 common so that we can say that whole expression is a multiple of 16, or we can say that a to the power 4 plus b to the power 4 minus 2 is a multiple of 16. So 4 times 2 is 8. You see that we got 2, but some expression do not involve 2. Let's write it out. M square plus m times 1 plus m square plus m times 2m square plus 2m. Once again, this expression is a multiple of 2, though this isn't, or it is. We'll see it soon. N square plus n square plus n times 2n square plus 2n. Now, why should it be that m square plus m is a multiple of 2? That's because m square plus m can be written as product of m and m plus 1. And then n square plus n can also be written as product of n and n plus 1. Rest of the expression we copy as it is. M square plus m times 2m square plus 2m, n square plus n times 2n square plus 2n. Now you see that m times m plus 1 is a product of 2 consecutive integers. If m is even, then the product is multiple of 2. If m is odd, then m plus 1 is multiple of 2. So anyway, the product is a multiple of 2. Similarly, n times n plus 1 is a multiple of 2. So this expression is a multiple of 2. This is also a multiple of 2. Definitely these two are multiple of 2. So the whole expression inside the curly bracket is a multiple of 2. So we can say that this is a product of 8 times a multiple of 2. So a to the power 4 plus b to the power 4 minus 2 is a multiple of 16. Whenever both a and b are odd.